Hi guys, in this video we are going to be doing the January 2020 Algebra 2 exam questions 1 through 12. So jumping right in, starting at question number 1. It says the expression the fourth root of 81 x to the 8th y to the 6th is equivalent to. These are huge key words. They don't necessarily tell you exactly what you're supposed to do, but you can look at your answers to identify what it's asking you for. So if I look at this and all of those, notice the radical is gone. That means I have to do something with that radical to then simplify and get one of those four choices. So that's what I'm going to tackle first, is this fourth root. Now there are three pieces underneath this fourth root. First, the fourth root of 81. When you're doing the fourth root, you're asking yourself what times itself 4 times will get me 81. Here's the nice part about multiple choice. I have either 3 or 9. If I multiply 3 by 3 by 3 by 3, I do get 81. So it's going to be either choices 1 or 2. It can't be 3 or 4. 9 times 9 is 81. If I do 9 times 9 times 9 times 9, it's way too big of a number. If you're not a mental math person, grab that calculator and type in the fourth root. So to get the fourth root, you go to math, go down to the nth root, and just plug in that 4 right there. Fourth root of 81 is 3. So either way you do it, you'll get that 3. Next, you have to do variables. When you're taking any root of a radical, you have to do TBO. Remember, top inside, bottom outside. So the inside number is an 8. When I'm rewriting this, it's going to be x to the 8 on top over the outside number, which is a 4, so it's 8 over 4. Okay, next I have to look at my y. Y is being raised to the 6th on the inside, so that goes on top. The 4 is on the outside, so that goes on the bottom. Now if I look at my choices, neither of them have that, which means I need to simplify a little bit further. 8 divided by 4 is 2. 6 divided by 4 simplifies to 3 over 2, and that leaves me with choice 1. All right, moving on to the next one. Chet has $1,200 invested in a bank account modeled by the function p of n equals blah, where p of n is the value in his account. Okay, then next, in dollars after n months. Chet's debt is modeled by the function this, where Q of n is the value of debt in dollars after n months. After n months, which function represents Chet's net worth? So the overall R of n that I'm trying to find is how much money he essentially has when this is the amount that's in his account and this is the amount of debt he has. Now think about that word debt. That is an amount that is owed. If you owe something, it's taken out of or taken away from the amount of money that you have. So I'm looking for subtraction. That means 1 and 2 are out. Now, all I'm doing is taking this debt away from this function. We are not including anything else in here. I just have to do that original function p of n minus the debt function, which was q of n. If I'm just subtracting those, that means nothing should change about them. That's going to be choice 3. If you look at choice 4, it added a 12 up here. That will not change anything for me. This is the amount of money he has. This is the debt. Simple as that. All right, number 3. Emmeline is working on one side of a polynomial identity proof. Choose to use to form Pythagorean triples. Her work is shown below. So step 1, 2, 3, and 4 are her steps. It says which statement is true regarding Emmeline's work. So if you look at the 4 choices before we even start working on this, 3 of them say that she made a mistake somewhere, and this one says that she was entirely correct. So really what we have to do is evaluate her work. So we have to think this is the original. To get from here to here, notice what changed. This part right here, she didn't even try to work with yet. That stayed exactly the same. But to get from this to this, she just squared everything in the parentheses. And to do that, I do have to take that squared and put it with both pieces. 5 squared is 25, and x squared is x squared. That means this step was done correctly. Great. Now to get from step 1 to step 2, notice this part stayed the same. So I'm going to ignore that now, and I'm going to focus on the blue boxed in piece. She definitely did some math to that. So this 5 became a 25, and this 5 became a 25. Is that how you square a binomial? No, it's not. If you were tackling this question, the next step you would take is to square it. You have to write it twice. 5x squared minus 5 times 5x squared minus 5. Now when I multiply this all out, 5x squared times 5x squared is 25x to the 4th. This right here, 5x squared times negative 5 is a minus 25x squared. Here, same thing, I get another negative 25x squared, and here I get plus 25. When I combine like terms, here, I end up with this, which is what should be here, but is not. So that means she made a mistake in step 2. So I look at my choices now. This one says there's a mistake in step 4 only, so that's not it. Her work's definitely not entirely correct. Both of these say step 2, so now I'm down to a 50-50 shot. Perfect. Now I keep going. So to get from her step 3, right now, even though I know that this is correct, we're not going to continue the math with that because we are assuming that we are Emmeline and we're seeing if she made any more mistakes. So I'm looking back at her work. From her step 2 to get to step 3. Let's take a look at what she did. She combined her x squareds and got 50x squared, and then she brought that plus 25 down. If you're simplifying, you are supposed to be combining like terms, so that is correct. That means this one is good to go. So now I need to take a peek at step 3 to step 4. Step 3 to step 4, she added the 50 and the 25 and got 75. 50 plus 25 is 75. However, this has an x squared and this one does not. Those aren't like terms and I cannot combine those. So that means step 4, she also made a mistake. So she made a mistake in steps 2 and 4, which is choice 3. All right, number 4, Susan won $2,000 and invested it into an account with an annual interest rate of 3.2%. If her investment were compounded monthly, there's some big keywords. Which expression best represents the value of her investment after T years? So first I need to remember my compounded monthly formula. And here it is. I also need to remember what everything stands for. A is the final amount, P is the starting amount, R is the rate as a decimal, and N is how often this is compounded. So looking through the problem, if A is the ending amount, P is the initial or starting amount, it says 2,000 was invested. That is how much you start with, so that's going to be P. The rate is your percentage, but it has to be written as a decimal, so that means that R is 0.032. And then N is how often it's compounded. This one was compounded monthly, so that means N is 12. Now, typically, you want to try and find a T, the time, to plug in for, but this one just says over T years. And also notice all of the answers have T in them. All that means is that we don't plug in any number for T. So now I'm going to plug in what I do have. It's A equals P is 2,000 times 1 plus R is 0.032 over N, which was 12, and that's raised to the 12T. Now if I look at all 4 of my choices, none of them have that. Exactly that, I should say. So what I need to do is simplify this a little bit. So since all of them have that 12t in some variation in the exponent, the next part that I'm going to want to tackle or simplify is this. So what I do is I grab my calculator and I'm going to type that in. It's 1 plus 0.032 divided by 12. So in there, the 2,000 is still here, but in the parentheses that I just plugged in, I'm going to end up with 1.0026 repeating. Just a reminder, that 7 at the end there just rounded up from what's on your calculator screen. So it's actually just 666666666, but that last 6 bumped that 6 up to a 7 on your screen. Okay, I still don't see 1.002 anywhere, but I do see this 1.003, which is really close. If you look at this, that 6 would bump that 2 up to a 3. So this is 2,000 times 1.003 to the 12t, and that's actually going to be my answer because they match up this one and this one. Now you might be thinking, like in class we've always talked about how you can't round early, you can't round early, you can't round early. We've stressed it a bunch. The reason that you're allowed to round slightly for this one is because it says which expression best represents. So it can be a super close representation, and 1.0026 is incredibly close to 1.003. So that's the best represented function. All right, number 5. Consider the end behavior description below. We need to remember what this represents. So this is x, and this is technically y. So as x approaches negative infinity, think about your x values. X's go from left to right. If x is approaching negative infinity, that means that x is approaching the left side of my function. Versus this one, where it's a positive infinity, x is going to the right. Now when I look at my y's, this one is saying that y is approaching positive infinity. Now y changes up or down. So if it's going to positive infinity, this one means up. And if this one's going to negative infinity, that means this one is going to be down. So what does that actually look like? As x goes to the left, y goes up. And as x goes to the right, y goes down. So that means my right side needs to be pointing down, my left side needs to be pointing up. Now you have 4 choices here. 2 of them are already graphed, so those are going to be the fastest ones to check first. So for number 5, for choice 2, the graph is going left and down, right and up. That's not the situation I have. In fact, it's the complete opposite, so it is not choice 2. So then I look at choice 4, they're both going down. I didn't want that. This side was supposed to be going up like I show right up here. So if that's the case, this one is also not my answer. So we got it down to a 50-50 shot. Notice that's happening quite a bit. So for choices 1 and 3, I need to see their graphs. Guess what? Calculator. So I go to my y equals, clear it out, and I'm going to type in that first choice, which is x to the 4th plus 2x squared plus 1. Oh, that wasn't a fun thing that happened. Let's try that again. X to the 4th plus 2x squared plus 1. All right, and then hit graph. So this graph looks like this. So I needed a graph to be going up on the left side, which is great, but it was supposed to be going down on the right side. So I can tell right away this one's not going to be my answer. So it does leave you with one last choice, but because you're a good student, you are going to plug that in and check it anyway, because your exam is super important. Every point counts. So I'm going to plug this in just like that and hit graph, and the graph looks like this, which is going up on the left and down on the right. So that one is my correct choice. Of course, it's the last one I checked. All right. Perfect. Number 6. The expression blah is equivalent to which of those following choices? So remember, those words, is equivalent to, doesn't necessarily tell you to like a specific thing to do. What you have to look at is your answers. So this entire function is going to be equivalent to one of 4 of the following. What I have to do is simplify it in some way to make it look like the following. So I'm just going to start with original given one, which is x plus a squared plus 5 times x plus a plus 4. And I'm just going to simplify it. So we already talked about this a little bit, but when you have that squared up there, it means you have to write it twice. So this is x plus a times x plus a, and that's plus 5 times x plus a plus 4. When I multiply this part out, I'm going to double distribute it. X times x is x squared. X times a is plus xa. A times x is also plus xa, and then a times a is plus a squared. Now I distribute the 5 through, that's plus 5x plus 5a, and then the plus 4 just comes down. I'm going to simplify this as much as I can, but it doesn't simplify much. The only things that combine are these. So it's x squared plus 2xa plus a squared plus 5x plus 5a plus 4. Yuck. But what I need to do is figure out which of those choices is equivalent to what I just found. So it has to be equal to this. Now, just looking at your answers, choice 1 has the letter A and the letter A in it. I should multiply this out. If I do, I get a squared plus 5a plus 4. But recognize, if you multiply something that only has a's in it, you're not going to get any x's out of it, and it needs to be equivalent to something with x's in it, so this one's out. Now with that same idea in mind for number 2, if I multiplied that out, it only has x's in it. If it only has x's in it, I'm not going to get any a's out of it, and that means it's going to be wrong. So this one's out, and I'm down to a 50-50 shot. Now I'm going to check choice 4 first because it's already simplified. This one I'm going to have to multiply out, and if I can avoid doing that, I'd like to. So let's see what these ones have in common. It has the x squared. A squared is right here. Let me just get rid of this for a sec. The next one is 5x, I have that. 5a, I have that. 4, I have that. However, this one is missing this term. That means that they are not equivalent. So this one is not my answer. All right, off we go. Now, I know that means that 3 probably is the answer, but you should check it just to be sure. So choice 3 is x plus a plus 1 times x plus a plus 4. Be careful multiplying this out. I'm going to start with the x first. This is going to be x squared plus xa plus 4x. Then I multiply the a through. A times x is plus ax, a times a is plus a squared, and a times 4 is plus 4a. And then lastly, I multiply the 1 through. 1 times x is just x, 1 times a is just a, and 1 times 4 is plus 4. Okay. Definitely can't tell if they're equivalent at this step. I'm going to have to combine some stuff. So there's only one x squared, that's gone. Then I combine my xa and my ax. Even though they're in a different order, I can just combine them because they're the same letters. This is going to be 2xa. 4x can combine with x, that'll get me 5x. 4a combines with a, that gets me plus 5a. A squared and 4 don't combine, they just come down, plus a squared plus 4. These are definitely in different orders, but let's just make sure they're the same. X squared matches up, 2xa, I have the 5x, I have the 5a, I have the 4, and I have the a squared. Those two are equivalent, so choice 3 is definitely my answer. All right, so quick equivalent to short. Oh, nope, that won't work for that one. Never mind, ignore me. I will explain it in the next one. Because once again, here are those words, is equivalent to. This one's a little bit trickier though. So it says, given that x is not equal to -2, the expression blah is equivalent to. So that means I have to manipulate this in some way to make it look like the answers. Now the answers are written in a certain form that you need to recognize. That form is quotient remainder form. Quotient remainder form means I have to do long division. So this divided by this. Little side note real quick too, this part right here where it says x cannot equal -2 is just some extra information saying that if you plugged in a -2 for x, it'd be -2 plus 2, which is 0, and you can't have a 0 in the denominator. So that's all that part is saying. It really doesn't add to the problem at all. It's just being mathematically correct, saying that if I do have this expression, x can't be -2. Okay, getting back to the problem. All of my answers are written in quotient remainder form, which means I need to do long division. However, this one has a shortcut to it. So I will tell you in this format, these in the blue underlines are the quotients. The remainders are written up here. So these are all of my remainders, and this one is a negative remainder, by the way. Notice all of the remainders are different. If you have a question like this and all of the remainders are different, you can go through and do the long division, or you can use the remainder theorem. The remainder theorem was essentially a shortcut theorem. It was a shortcut that we learned to just come up with the remainder. I don't need to even know what these are. If I come up with the remainder, I'm done already. So the remainder theorem says that you have to take the denominator and figure out what x value would be excluded. In this one, it's -2. We already talked about that though. So once I find out that x equals -2 is the thing I have to plug in, I'm going to plug it into the top. This is the remainder theorem. If you don't remember the remainder theorem, give long division a try. It'll still work, but the remainder theorem is just a little bit shorter. So on top I have 2x squared plus 5x plus 8, but everywhere I see an x, I'm going to put a -2. So here is a -2, and here is a -2. When I plug that into my calculator, I will get a 6. Make sure you put parentheses here. If you're squaring a negative, you have to put parentheses around it. So if I get a 6 right here, that means that that is my remainder, and that's going to be choice 3. There have been a lot of choice 3s so far. Stay confident they are correct. Okay, so another way to do an equivalent, and this is one of those shortcuts. Okay. Anytime you see the words equivalent to and you only have one variable, that's why it really wouldn't work for that one, you can plug these into your calculator and graph them. If I plug this into my y1, plug this into my y2, y3, y4, and y5, the equivalent one is going to be the exact same graph. I don't want to plug these all in at once, by the way. What I meant by that is like plug this into your y1 and y2. See if those are equivalent. Because that wasn't the answer, there would have been two different graphs. Let's say this one looks like this and this one looks like this. They're not equivalent, so that would be right out right away. So that one's it, and then you would try this one as y2. You'll plug that in to see if they're equivalent. If they're not identical graphs, they're not equivalent, so that one's out too. If you graphed choice 3 as your y2 and you graphed choice this whole thing as your y1, your original, you would notice they have the exact same graphs, which means that they are equivalent. We're going to do more talk on shortcuts in class, but I just wanted to show you that one real quick. All right, and looking at number 8. Which situation best describes conditional probability? Conditional is just another word for given. Okay, it's the whole idea of there being conditions on your probability. Like, for example, someone has black hair given they have blue eyes. That's a condition. And that condition is also known as the word given. So I read through my choices. Number 1 says finding the probability of an event occurring 2 or more times. That's not a given example, so I don't want that one. Number 2, finding the probability of an event occurring only once. Nope. Finding the probability of 2 independent events occurring at the same time. That's also not a given. Number 4, finding the probability of an event occurring given another event had already occurred. It's going to be choice 4. You just need to know terminology for that one, that conditional means given. All right, next one, number 9. Which expression is not a solution to the equation 2 to the t equals the square root of 10? So that means 3 of these are written in a different format, but they are a solution. One of them is not. So what I'm going to have to do is first solve this. Now, the answers kind of give you a hint because they all have the word log in them that you're going to need logs for this. But if it wasn't a multiple choice, you would still need to know how to solve this. If there's a variable in the exponent, you have to use logs. So this is the log of 2t equals the log of the square root of 10. Now, the logs say that I can take my exponent and bring it to the front. So that t is going to go in the front here. Log of 2 equals the log of the square root of 10. Now to finish solving this for t, I need to get rid of the log of 2. Since they're being multiplied, I'm going to divide by the log of 2. Now I could plug this into my calculator and get a decimal, but that's not really going to help me over here. So what I'm going to do is leave it as that. It's t equals the log of the square root of 10 over the log of 2. Now, something else that we need to know is the change of base formula. So I'm just going to go over here and review that with you real quick. If I have the log, for example, base 3 of x, and this is completely separate from this example, by the way, the change of base means I'm going to rewrite this without the base. So this is going to be the log of x divided by the log of the base, which is 3. That's how I can rewrite it to not have a base. So that means that this one can be rewritten as the log base 2 of the square root of 10 going the other way. Now, this matches up with this, but it's asking which one is not a solution. This one is, so that one's out. Okay, now choice 1. Think about what we just did up here. I took the variable in the exponent and I brought it to the front. That means I could have also taken this and moved it back up here. They'd be equivalent. This one has the number in front, so I'm going to move it up here. This is the same as log base 2 of 10 to the 1/2. And we also need to remember that an exponent of 1/2 is just a square root. This is log base 2 of the square root of 10. And once again, that's equivalent to this. So if this is equivalent, that means it is a solution, and we're looking for the one that's not. So that's not my choice. Okay, now these other two are a little bit trickier, but I'm going to do the log change of base to it, the log of 10 over the log of 4, and the log of 4 over the log of 10. Kind of tricky for this one, but look at this piece right here. It's the log of the square root of 10 over the log of 2. If I square root both of these, this will have a square root on top, and the 4 would be 2. This one's going to be an equivalent, which means it's not that, it's got to be this one. But you can kind of tell that because the 10 is on top for this one, and the 10's on the bottom for this one. If I square rooted these, it'd be the log of 2 over the log of the square root of 10, and that would be flip-flopped, and that's not the case. So choice 4 is the only one that's not a solution. Now, here we go with a quick little shortcut. So over here, when we got to the answer, I said to you that we shouldn't plug this into the calculator and get a decimal because none of the answers had a decimal. However, if I went over here and I typed it in, anyway, the log of the square root of 10, and this is a huge shortcut, by the way, guys, hear me out. The log of the square root of 10 divided by the log of 2. I end up getting that decimal, so I'm just going to write that decimal down. It's 1.660964, blah, blah, blah. Now that means that if these are also solutions, 3 of them are also solutions, they would get me that same decimal. So this first one that I'd want to type in is 1/2 log base 2 of 10. So 1/2 is 0.5 log base 2 depends on your calculator. To the people with my calculator, you type in math, alpha, math, and it gives you the option to type in the base, and this one, I forgot the base already, was base 2 of 10. Notice I get the exact same decimal. This one is the 1.66, blah, blah, blah. So that one is equivalent. That means it is a solution, and I'm finding the one that's not. To my 83 calculator people, you have to plug it in with the change of base. So you would type it in as 0.5 times the log of x. Or sorry, not the log of x. I was looking at this one over here. Oh my goodness gracious. This one is the log of 10 divided by the log of 2. So the log of 10 divided by the log of 2. 1, 2, 3. And you get the same answer. You just don't have that log base typing option, so you just have to type it in as the log of 10 divided by the log of 2. But notice you get the same answer. So if this is my solution and this is also the solution for this one, and we're finding which one is not, that wouldn't be my answer. So you can go through and type them all in. I'm just going to plug in choice 4 so you can see that it's not equivalent, and I'm going to do it with the math alpha math. It's log base 10 of 4, and notice that one gets you 0.602, which is not equivalent, which means that one would have to then be my answer because it's not the solution. The solution was 1.66. And again, for my 83 calculator people, you can plug that in as the log of 4 divided by the log of 10. And there it is. Alrighty. Moving on to number 10. What is the solution set of x equals the square root of 3x plus 40? So we solved a bunch of these on our FIRS. To get rid of that square root, I have to square it, and what I do to one side, I have to do to the other. So when you square the right side, the squared and the square root cancel each other out, and this will just be x squared equals 3x plus 40. Now to solve this, when I have an x squared and an x, I'm going to have to get it equal to 0 and factor it. So I'm going to move these two terms this way because if I move the x squared this way, it would be a negative x squared, and that would have to do AC. I do not want to do AC, so it makes more sense to me to move the other two terms this way. So I end up with x squared minus 3x minus 40 equals 0, and now I need to factor it. So it's an easy trinomial because I have a positive 1 out in front here. I need the two numbers that multiply to negative 40. That'll add to the negative 3 in the middle. It's going to be 8 and 5, and my 8 needs to be negative. So this will be x minus 8 and x plus 5. And then when I tee it up, I get x equals 8 and x equals negative 5. And then I see my answer and I pick choice 1 and I'm all excited, but that's wrong. It is not choice 1. The reason it's not choice 1 is because when you have a square root equation, you have to remember to check your answers. So I'm going to have to reject one of these, and I guess you guys can already kind of see which one's going to reject because the other option's not there. But I need to check these in my original. So if I check 8, it'll be 8 equals the square root of 3 times 8 plus 40. So I plug that into my calculator. I already know that the left side is 8. Then I plug in the square root of 3 times 8 plus 40, and I get 8. So that one works. Now I have to plug in negative 5. So I do negative 5 equals the square root of 3 times negative 5 plus 40. So I know the left side is going to be negative 5. Then I plug in the square root of 3 times negative 5 plus 40. And I get positive 5. Those are not equal. That means this one rejects, and my answer is choice 2, which is just 8. If they both rejected, that's what this looks like. It's an empty set. They didn't both reject, so that's not my answer. And negative 4 and 10 aren't even close, so those ones are out. All right, number 11. Oh, quick shortcut tip for number 10, by the way. If you have a question like this, what is the solution set of x? I went through and I actually solved it. That's the right way to do a question like this. And then you go through and you check your answers and plug them into your original. Now, because it's multiple choice, the exam is literally saying to you, hey, it's either going to be this, 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 or this. So what you can do is just test your answers. If I tested choice 1 first, I would have plugged in negative 5 and realized it rejected. So that means that answer's out. If I tested this one, I would plug in a negative 4. If you plug in negative 4 to this, just to see if it works, I do the square root of 3 times negative 4 plus 40. and I get that negative 4 equals 5.2. That doesn't work, so that one's out. Okay, when you check the 8, it does work, so you would have picked that one. So you technically don't even have to do all of that. You can just check your answers. However, doing it both ways. Remember, you guys have 3 hours to do this exam. Doing it both ways is the smartest option. Do it the right way, and then just check it with your calculator. And number 11, consider the data in the table below. What is the probability that a randomly selected person is male given that the person is left-handed? So this is going to be the probability of male given left-handed. We need to know the probability formula. It's going to be male and left-handed on top over the given. The given always goes on the bottom, so left-handed goes on the bottom. So for male and left-handed, I have to find their intersection. Male is right here, male is right here, left-handed is right here. They intersect at 13. So it's going to be 13 over the total amount of left-handed people. Now this one didn't give me the total, but I can do some simple math real quick. These are the left-handed people that were male and female, but I need the total, so it's going to be 24. So it's 13 out of 24, and that is choice 4. All right, one more for this video. It says the function n of x equals 90 times blah, 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 can be used to predict the temperature of a cup of hot chocolate in degrees Fahrenheit after x minutes. What is the approximate average rate of change? There's some key words of the temperature of the hot chocolate in degrees per minute over the interval from 0 to 6. So, AROC. I need to know my AROC formula. It's y2 minus y1 over x2 minus x1. Something else I need to know is that intervals are x values. So when it gives me an interval, it's not giving me a point x comma y. No, 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 no. The interval is 0 comma something through 6 comma something. This is my x1, y1. This is my x2, y2. What I need to do is now plug those into my given function and find out what the y values are. I'm just going to rewrite the function over here so my calculator doesn't cover it, and I'm going to plug those in. So the first thing I have to do is 90 times 0.86 raised to the x, and this one x is 0. And for this one I have to do 90 times 0.86 to the 6th plus 69. Good, so I'm going to plug that in, clear this out. So it's 90 times 0.86, close my parentheses, to the 0, plus 69. So for this one, I get that y1 is 159. Now I plug in that exact same thing, 90 times 0.86 raised to the 6th plus 69. And I get a yucky number, 105.411051116. Okay. Am I allowed to round early? The correct answer is no. I do not round early. That's what I'm going to use for my y2. So for average rate of change formula, I'm going to plug this in. It's going to be AROC equals y2 is 105.411051116 minus my y1, which was 159, over x2, which was 6, minus x1, which was 0. So I grab my calculator and I type that all in. I can go up and copy and paste to my 83 people. Press second enter and it'll copy and paste your answer. Or of course you can just type it in, that's fine too. So remember, you have to type in the top first, enter, then divide it by one number on the bottom. On the bottom, this is just going to be 6. So I divide by 6, and that's going to be my answer, that AROC is negative 8.9314911473. Oops. Which is going to be choice 1. All right, that's it for this video. We'll pick up with number 13 in the next one. If you guys have any questions, please reach out.